First of all, my name is Anthony Blayong George. My matrix number is B0918100068, and I am from 4BMMM1/2. So today I'm going to present about my bachelor degree project, which is entitled Asset Maintenance Strategy in Spare and Replacement for Hvac in Oil and Gas Industry. Alright, so this presentation consists of introduction, problem statement of the project, objectives, scope of the project, literature review, methodology, result and discussion, and lastly, the conclusion of the project. Alright, so for the introduction, we all know that asset management is becoming more important in boosting operational efficiencies because of increased competition and tighter margins within oil and gas companies. The problem of stress acting upon structure is one of the fundamental problems that can cause a failure or a fatal and hazardous result if it is not counted or studied deeply. Thus, in this project, we will focus more on studying the methods and tools that can be accessed and used by everyone in generating data for displacement due to the stress acting on structure. Alright, so in this slide, I'm going to explain more about the problem statement that I found for this thesis. So as for the advancement of technologies in the world, it is quite hard and it is very competitive in assuring which is the best tool or devices used to solve problems. Asset integrity is very crucial throughout the asset life cycle, from operation to replacement and decommissioning. As a result, there is always an impediment and a need to discover a solution to balance the asset design, repair, and replacement costs, as well as the effort expended in terms of finance, time, and energy through the life cycle of the asset. So as we can see, the figure beside, it shows that asset life cycle is very important in an organizational strategic plan so that it can cut time, budget, and also more efficiently, it can give much more benefits to the company. I'm going to explain about the objectives that needed to be done or needed to be studied to complete this bachelor degree project. So first of all is that it is to study the importance of stress analysis on its effect towards the behavior of the material and defects. Second one is to investigate the finite element analysis method on the parts and components of HVAC structure. And lastly is to design and build a monitoring device used in displacement sensing by implementing Internet of Things to be used for field activity circulating around the strategy of asset maintenance. So we go move on to literature review. So this thesis writing and study is to focus in creating an alternative and can correlate to the digital image correlation by using different tools using structural inspection. It will revolve more on the understanding of stress analysis and in the finite diagram analysis, whilst taking count of asset integrity in this chapter. Besides, this writing are also formulating with the asset maintenance strategy for spare and replacement, where the fundamental aspect of Internet of Things are also tested to bring upon a new study of artificial intelligence to maintenance point. First studies that I studied is that fundamental of stress analysis. So this is the introduction on what and how stress concept can be implemented. The second one is about finite element analysis. So this finite element analysis consists of the principles of finite element analysis, finite element equations, and also finite element analysis nodes and elements. So next is about the finite element modeling. So this is about the modeling that needed to be done in order to make a finite element analysis. So this chapter consists of a boundary condition, the loading, and also the meshing of the modeling. So next is the stress analysis criterion. So it consists of the von Mises stress, the first and third principle of stress, the displacement of the model, and also the safety factor of the structure. So next is about the fatigue analysis. So basically fatigue is the development of damage in a material subjected to variable of loads and strength on a cycle by cycle basis. So we move on to the Internet of Things. So here we have the working principles of IoT, the fundamental characteristics of IoT, and also Internet of Things used in current entity testing. And next one is about the structural inspection of a bracket to fulfill the modeling of the finite element modeling. So in the chapter, it basically says that about the design method for the frame was summed and incorporated towards the design code of the finite element analysis based on the foregoing analysis. So the next chapter in this thesis is about methodology. So in this chapter, it will focus on the finite element modeling, the mechanical properties, loading type, stress analysis, and the meshing elements. Besides, this chapter also will explain about software and hardware used for Internet of Things setup, which is Arduino IDE, and for the hardware, ESP8266 Node MCU. So first of all, is about the finite element modeling. So we need to come up with the design to do a testing on the modeling. So here we choose a hanger type support and also a stand type support. So and then after that we need to have the analytical setup of the model. So we need to have the modeling testing criteria. So the testing and the objective for this analysis need to be determined in the first stage of the analysis. This will include the loadings or the force that is going to be exerted on the model. Alright, so next is meshing element and convergence. So the size of the mesh is dependently related to the accuracy and the value of mesh are essential criteria for the meshing of the elements. The reliability of the result achieved in finite element analysis is governed by the mesh size. So next is the operating conditions in order to do the testing on the FEM. So first of all, we need to have the loading layout. So thus, the amount of load exerted on both support is the same. On the stand support, the force exerted is 1000 Newton, while for the hanger support is also 1000 Newton. This is to make the comparison between the support so that the stress can be shown where the different displacement can be seen. So next is the constraints of the modeling. So the aspect ratio of the various finite elements can change. Thus, the constraints of the modeling need to be done because it can affect the data if it is not taken seriously. So we move on into the IoT software. So first is that we studied about Arduino IDE and also Blink application. So for software, the programs are written by using Arduino software IDE, which are called sketches. The Arduino board links to a computer via USB and then to the Arduino development environment. And for the interface is using Blink application, which are particular made to be used via gadgets and mobile phone. And next is study the methodology is on the IoT hardware. So in this methodology, the method and tools used, which is the ESP8266 not MCU and also ultrasonic sensor module HC-SR04. Hence, the setup of both the software and the hardware of the whole of IoT system is needed to be done to achieve the desired output. The schematic diagram is used to connect the ultrasonic sensor to ESP8266 not MCU. Here are the schematic diagram. So this is included in the setup of IoT interface and also hardware. So the ultrasonic need to be wired to ESP8266 not MCU as shown in the schematic diagram. Alright, so next uh, we have a program sketch. So and also the declaration of a program. So declaring the variable is recommended to make it is easier to use its value in the future. So by declaring the program, we can set up on which hardware we use, such as the connection of ESP8266 not MCU to the Blink application. So once again, this methodology is based on the tools and methods to use in studying the displacement by using a different tools, which is by using a finite element analysis or as we call it Autodesk Inventor, and also by using the Internet of Things in studying the displacement or in using it in asset integrity. So next we will going through to the results and the discussion of this thesis. So here displacement, bond misses stress, first principle stress, third principle stress, and also safety factor are the analysis result from the simulation by using Autodesk Inventor 2021 software is shown on the analysis of the Hvac support that is studied in this thesis based on the finite element modeling. And also, here it will show the preliminary testing results of the Internet of Things or IoT, which is the detection of displacement through a real-time based data taken to see the implementation of IoT in detecting and giving the data to Blink applications. Furthermore, the errors and the synergizing of FEA and IoT were discussed in this chapter. First, the result that we got is about the component analysis. So here we have the displacement that is undergone by this type of structure. So the minimum displacement of the stand type support is 0 millimeter. Meanwhile, maximum displacement is 0.2333 millimeter. Thus, for the hanger type support, the minimum displacement is 0 millimeter and maximum displacement is 0.00119 millimeter. So the next result we have is about a stress analysis of mechanical properties. So von Mises stress, as for the stand type support, von Mises stress shown is at the minimum unit is at 0.3015 times by 10 to the power of negative 3 megapascal, whereby its maximum unit is 16.9794 megapascal. And for the hanger type support, the von Mises stress shown is at the minimum unit is 0 megapascal, whereby its maximum unit is 0.221 MPa. So we continue on the stress analysis of mechanical properties. So the first principle, stress and strain of both type for the both uh, type structure. So for stand type support, the first principle minimum stress is negative 1.48436 MPa, whereby its maximum stress is 15.5141 MPa. Meanwhile, for its first principle, minimum strain value is that negative 1.021 to the power of 10 negative 7, and its maximum strain is that 6.9103 to the power of negative 5. Thus, for hanger type support, first principle minimum stress is negative 0.0425 MPa, whereby its maximum stress is 0.2238 MPa. Thus, meanwhile, for its first principle minimum strain value is that 1.66 times by 10 to the power of negative 9, and its maximum strength is that 1.142 times 10 to the power of negative 6. So for the third principle, stress and strain, is that for stand type support, uh, the minimum stress is that negative 11.935 MPa, and its maximum stress is that 2.263 MPa. And for its third principle strain, its minimum value is that negative 5.898 times to the power of negative 5, and its maximum strength is that 1.009 times to the power of negative 6. Hence, for the hanger type support, third principle, the minimum stress is that 0.1838 MPa, and its maximum stress is that 0.0374. And for its third principle strength, its minimum value is that negative 8.8082 times by 10 to the power of negative 6, and its maximum strength is that 4.6724 times by 10 to the power negative 9. And we still continuing on the stress analysis of the mechanical properties. So here we have the equivalent strength of both the structure, and for the equivalent strength for the equivalent strength of stand type support, it shows that the value of its minimum equivalent strength in total is 1.3782 times by 10 to the negative power of 9, and maximum is 7.0089 times by 10 to the negative power of 5. Thus, for hanger type support, shows that the value of its minimum equivalent strength in total is 0, and maximum is 1.019 times to 10 to the negative power of negative 6. Thus, for the safety factor, it can be analyzed that the structure is in a good criteria of safety factor, but the condition on the structure can be assumed that where the failure can happen. So for stand type support, it shows that the failure can occur on the nut and bolt of the structure. And for the hanger type support, the result shows a much more deflection at the beam. So next is the IoT preliminary testing. So first, the result shows that the IoT hardware functionality. The functionality of the sensor is to provide an efficient hardware in measuring displacement while giving it handy to carry equipment, and is easy to be linked anywhere and anytime. So second one, the result shows about the IoT interface. The result shows that there is latency due to the problem with internet connection, but the data and the reading detected by the sensors can be retrieved to see the activity of the displacement. And lastly is the real-time data. The data can be sent to give a real-time report on what is happening on the structure or detected by the sensor. So this is the widget of the Blink interface. So here we can see the graph is moving, where it is sensing the displacement of an object via real-time data. As for the discussion, it can be said that there are three main groups in decomposing the error in FEA, which is first, modeling errors due to simplification as we try to remodel the real world yet are not able to do it exactly 100% similar. To discretization errors that arise from the creation of the mesh. And third is the numerical errors of the solution of the FEA equations. So in this thesis, both tools can give a data on the displacement. In the model testing model of FEA, the displacement of the structure is modeled, and thus for the IoT, the changes of the displacement are also can be tabulated as per real-time data. Thus, it can be synergized by giving it a clearly objective, such that in performing a predictive maintenance on a structure. Now, as a conclusion, in an asset maintenance approach, there is a key fundamental factor that can make FEA and IoT function together. Both tools can provide data on displacement. The displacement of the structure is tabulated in the FEA model testing, and so the changes of the displacement can be tabulated as real-time data in the IoT. This can bring a new big thing for technology where both tools can provide data with accuracy for model testing and also monitoring. Thank you.